Okay, hi. I think I'm recording. I can just need to double check and make sure I'm recording. I am. So this is from the Candle Hunt material that's online, and I don't know why that just got bigger. Um, we have what's a Venn diagram over here. A Venn diagram is typically you have circles of topics, and everything that's inside that circle is the thing that that set represents. And so here I've got a set that is birds, and I got another one that's bats, and these are characteristics of those. I can name these sets. I could call this set A and this set B if I wanted to. And everything that's not in the set is not a characteristic of birds or bats. So um, six legs is not a characteristic, whereas wings and insects is a characteristics of both. This section in the middle is called the intersection. And birds have feathers and lay eggs, which bats or do not. That's why that's out here. And bats have teeth and sleep upside down, which birds do not, which is set out here, set upside out here. This is a really powerful way to represent certain relationships. It's also a good way to do two-way tables, which I need to erase to make that work. And a little technical difficulty. Okay, that worked. Let's scroll down. I like pointing out this. This is, let me shrink this down a little bit more. This is a really interesting Venn diagram. So once again, the name of these things with these circles in here are called Venn diagrams, VENN diagrams. Basically, it's circles, which once again, have categories of things in there. And one of the things I like about this particular picture is Great Britain here is what's called a subset of the United Kingdom. I can say, well, everything that's in Great Britain is definitely in the United Kingdom. Whereas the Isle of Ireland, part of the Isle of Ireland, Northern Ireland, is in the United Kingdom, whereas the Republic of Ireland is not. So this is kind of interesting way to really relate relationships. And if you scroll down here, you will notice there is tons of questions that you can get from this kind of simple relationship. So it's really interesting to write things out this way, to define relationships, what is and is not certain things. And there's some other information down here. So usually I ask you to read the summary if you need some help. There's another example down here, which I'm going to get out my annotation to mark this up a little bit. And so once again, this is another Venn diagram, VENN. And I've got a bunch of letters already in here. I'm going to call this set X and this set Y. And X is defined as people who are taking chemistry. And so one way you can define a rule is, or a set is a by rule. So these are chem students. And then Y is the other set. These are biology students. And then the letters in here particularly represent like what's the student. So maybe this is Alan and Bob and Kathy and Denise or whoever it happens to be. Or this could be student A, student B. But from looking at this, I can say, oh, there's one student who takes chemistry. There are 3 students who take both chemistry and biology. There's, I think, 6 students there. And there are 2 students out here, and that does add up to 12 because they told me there would be 12 in there. And just a couple of other things that you will see in the Desmos, which you should definitely do. This area in the middle here. Once again, this is called the intersection, which is a good name because it's where they intersect. It is, you could also call it the overlap because the 2 circles overlap, but there's a way to write this. And so if I want to talk about that area in the middle, I can talk about X and what looks like kind of an upside down U and Y. And so this is the symbol for intersection, and it means those things that are characteristics of both or belong in both sets. If I want to specify everything in both circles, that's what is known as the union. So the union is a U, which is great. And so X union Y, that's everybody who's in both. Let me color code this. So everybody in both is all 10 of those people there are in both. Okay, that's the union. And very often this will be represented with an or. If I ask you who is in chemistry or in biology, it would be all of them, because chemistry or biology implies they're in chemistry, they're in biology, or both. So what we do is called a logical or here. It means one, the other, or both. Whereas we say in grammar sometimes, it doesn't always mean that. Whereas this over here is often called an and, because it's like, are they in biology, chemistry, and biology? That's the area in the middle there. The one last thing is the two people out here. They're part of this whole universe. Let me change colors again. This is usually in a box. And this box, which includes everybody who's in chemistry and everybody who's in biology, also includes people who are in both. This is often known as the universal set. And I can represent that by a rule. I can say it's 12 students. I can actually list out those letters, A, B, C, D, E, but that's the universal set. I'm going to show you one more example, and then I think I'm going to be done. So if we clear this out, close that, and I'm going to go back to the problems that you hopefully have looked at already. Okay, 50 students. If I didn't tell you 50 students, you would have to add up all these things in my Venn diagram down here. And the question here was, do you have a cat or do you have a dog? And this is not, do I prefer one or the other, which we've seen an example like that before. This is which one? And I definitely have a dog. All right, I think the dog has calmed down. So I'm going to call this set C and call this set D, not quite. So if I ask you, do you have a cat? It's everybody here in the cat circle. So I have to add those together. Cat, there's 13 people, the 8 plus the 5. Cat or a dog, once again, one way we can write that is cat or a dog, the union. Well, that's the 8 plus the 5 plus the 14, which I think adds up to 27. That's my or. A cat and a dog. You write as, and actually, let me change colors. Let's do and. If you have a cat and a dog, that's this area in here, so that's easy enough. It's 5, no adding required. Do not have a cat. Change colors again here. Okay, so cat's here. So everybody outside the circle here is a cat. This is often called the complement. And we've seen this word before, but we've used it in a different context. If we had a 40-degree angle, the complement to that angle was 50 degrees because complementary angles add up to 90. So it's what gets me to 90. The complement in this situation is what gets me to the universal set. So if I've got 13 of them in there, the complement of cat is everybody outside the 13. So the 50 total minus the 13, which is 37. This can also often be written as not C, because it's not the cat set, or C prime. That also means not the cat set. So everybody outside the cat set. So that is 37, and I forgot to write that in, was 5. And then finally, do not have a cat or a dog. That's these guys out here. Okay, those 23. And the question I don't ask there, I didn't ask any percentages for any of these. If I ask you the percentage or the chance of picking like somebody who has a cat and a dog at random, would be 5 divided by 50. If I ask you how many people had a dog, it would be 19 divided by 50. What percentage? All right, let's see if I've got time for one more. The next one, which I can't get to while this thing is open, looks like this. And this is one where, once again, they've defined the sets as multiples with a rule. So the this rule over here, let's call this set, what letter haven't we used yet? Let's call this set M and this set N, okay? So M is defined as multiples of 3, sorry, of 2, and N is defined as multiples of 3, okay? And we are just gonna do 1 through 12. So my universal set, U stands for universal, don't confuse it with union, is 1, 2, 3, and this is what's called a partial list, where I don't list them all out, but once it's obvious that I've set up a pattern, I can just do that. So this is what's called a partial list, and it's another way to define a set. You're gonna see all this in Desmos here shortly. And I can start putting these in here. 1, well, it's not a multiple of 2 or 3, so it's out here. 2, definitely a multiple of 2. I can divide that by 2. 3, definitely a multiple of 3. Notice I'm not putting it in the middle because 3 is not divisible by 2 and 2 is not divisible by 3. 4 here. 5 doesn't fit in either one. 6. Where does 6 go? Right, 6 goes in the middle. Okay. 7 doesn't go anywhere. 8, where does 8 go? Right, 8 goes there. What about 9? 9 goes there. 10, where's 11 go? Right, 11 goes outside, and then finally 12 goes right there. All right, I think I've done that correctly. Notice, and I'm stopping. I know to stop at 12 because they told me that. There's no negatives in here. There's no zeros because that was not part of our universe. And then there's a bunch of questions I can answer about it. I think that is plenty. I don't think I need to add anything else. So go do the Desmos. And you missed out on doing it live in class because I would have given you feedback while you were doing it. But do the best you can and then email me questions if you have any. Ciao.